This video instruction is for Chapter 2, Refrigeration, questions 9 and 10. A little better explanation of the math involved in these questions. In question number 9, it gives you the following properties for a substance: heat in a solid state, heat in a liquid state, latent heat of fusion, latent heat of vaporization, and a melting point of 40 degrees. It says calculate the amount of heat which will be absorbed when 15 pounds of the solid substance at a temperature of 30 degrees is changed to a liquid at 44 degrees. And the important thing to note here is that the melting point is 40 degrees, so you are changing it from a solid to a liquid. So the first thing to calculate is how much heat it takes to bring it from the 30 degrees to its melting point as a solid substance. 15 pounds times the specific heat of a solid in a solid state is 0.4, and you're raising it 10 degrees from the 30 degree temperature up to 40, the melting point. So you'll need to calculate this and put a result there. The latent heat of fusion, because it is changing from a solid to a liquid, is 15 pounds times the 120 BTU per pound. Put that number there, and then after it is turned to a liquid and you're heating it up 4 more degrees, going from the melting point up to 44 degrees, you have to calculate 15 pounds times the specific heat in a liquid state times the 4 degrees. Once you have these three numbers, you will add them to a total, and that will be your answer right here. For question 10, it says using the substance in question, that should actually say question number 9, has a boiling point of 120, specific heat of vapor is 0.3. Calculate the amount of heat required to change 15 pounds of the substance from a liquid to a temperature of 100 degrees to a vapor temperature of 130 degrees. So this time we're actually going to use the latent heat of vaporization. To heat this from a liquid, 15 pounds of liquid, we need to know to the boiling point is actually 120 degrees. So we're raising it from 100 degrees to 120. And back on question number 9, you saw that the specific heat in a liquid state is 0.9. So it's 15 times 0.9 times 20. Again, latent heat of vaporization, this time because we're actually going to a vapor, we're going to use 15 pounds times the 800 BTU per pound, which was its latent heat of vaporization. And then after it is a vapor, we're adding heat to raise it another 10 degrees from 120 to 130. So 15 pounds times the 0.3, which is given here, is specific heat of the vapor, times 10. So once you find the result of this calculation, and this calculation, you add them up, and the total will be your answer.